All right, here we go. Test review. Here we go, okay? For ellipses and hyperbolas. All right, so first things first, constant needs to go over. Looks like we're going to be completing the square here. Okay, and look what it's asking us. It wants us to graph it, and we only need to find the center, foci, and eccentricity. And I apologize, I do not know why the focus is messed up. Exposure. Sorry guys, I apologize. Gotta hit focus there. There we go. Okay, that should be good now. All right, so we gotta move that 400 over, and then we need to factor out now. How do I know this is an ellipse? Look at both of the x squared and y squared are positive. If this was a hyperbola, then one of these would be negative. So we're going to organize and factor out. We're going to skip some steps here. This is the test review. So 9, and that's going to leave me with x squared plus 8x plus 16, which that's going to leave me with y squared minus 10y equals a negative 400. Okay, now we're going to take both the b values here, divide by 2. 8 divided by 2 to the second power, that's 4 to the second power, which is 16. Negative 10 divided by 2. Negative 5 to the second power gives you 25. Okay, now recall, since you factored out here, when you add to the right side here, it's going to be plus 9 times 16. You don't just add the 16. You got to do 9 times it because you factor out a 9. Plus 16 times 25 because we factored out a 16 and we were adding 25 after doing the completing the square part. So now it's going to look like this. You're going to have now 9. Okay, we did 8 divided by 2. We got 4, so it's going to be x plus 4 to the second power plus 16. When we did negative 10 divided by 2, we got negative 5, so y minus 5 to the second power equals, that's where I'm using my calculator here because there's a lot here, so negative 400 plus 9 times 16 plus, and you get 144. So recall our last step, okay, our last step is to go ahead here. We want 1 on the right side here, so we're going to divide everything through by 144. And so my equation is going to look like this, right? If you're not sure what 9 over like 144 simplifies to, just plug in your calculator, so it's 1 over 16. So we're going to get this, we're going to have x plus 4 to the second power over 16 plus, fraction button again, 16 over 144, simplifies to be 1 over 9. Okay, so if we were asked for our standard form for our equation, it's right there, right? So center, opposite h and k here, so my center is going to be negative 4, positive 5. Okay, let's go ahead and write out the rest of our characteristics. We know with ellipses, remember, bigger value is always a squared, so a squared equals 16. So a equals 4. B squared equals 9. B equals 3. And then c squared formula is c squared equals a squared minus b squared. A squared minus b squared ellipses. Make sure you have your formulas, guys, with you for the test. 16 minus 9, so that means c squared equals 7. Therefore, c equals the square root of 7. which is approximated to be, so it can help us graph, 2.6. Two, three, four, five. Okay, so for our foci, because a squared is under x, we know this is a horizontal major axis. So if we know c is equal to the square root of 7, then it's just going to be this. It's going to be negative 4 plus or minus the square root of 7, comma 5, because we know our foci are going to be to the left and right of the center. So the only value that's changing is the x. The y value is not. Eccentricity is c over a. So c is square root of 7 over a, which is 4. Let's go ahead and graph. So our center is negative 4, 5. So there's our center. A is 4, so I'm going to go left and right 4 for the vertices. Vertices, left 4. Co-vertices, B is 3, so we're going to go up and down from the center 3. And then our foci, what do we get there, is 2.6. And there we go. So let's go ahead and let's graph. All right, and there we go. Okay, so write the equation of the ellipse in standard form. Let's go up. Okay, so we want to write the equation of the ellipse in standard form, which is tangent to the x-axis and y-axis, and the center is negative 2, 5. Okay. Okay, so let's go ahead and let's graph that, negative 2, 5. So there's our center. So we know it's tangent to it. So for it to be tangent to it, that means that one of my vertices, we don't know if it's the actual vertices or co-vertices yet, has to be directly to the right of the center, because for anything to be tangent to the center, it has to be a direct straight distance that makes it perpendicular, right? So we know that this is one of the vertices right here. And then to be tangent to the x-axis, I wish I would have drawn it better, sorry. Even though I'm not an artist, I am a perfectionist when it comes to that. Means here's one of our other points. Because if I was to go straight down from here, it would be perpendicular to the x-axis, making it a right angle, therefore. Okay, so what does that mean? Well, the larger distance is going to be a. So in this case, we went down 1, 2, 3, 4, 5. So we know then that a is equal to 5. Okay, we know then right here, this has to be b. And so b is going to equal 2. So if we have our center and we have a and b, we can write our equation out. Okay? So our equation is going to be this. It's going to be x plus 2. Now, this distance is longer going vertical, so that means a is going to be under y, b is going to be under x. So if b is 2, 2 squared then would be 4 plus y minus 5, all to the second power, sorry, over a squared. A is 5, so a squared would be 25. So there you go. So there is your equation. We can go ahead and graph now. From the center, we're going up 5. 1, 2, 3, 4, 5. Vertices, vertices. We know this now is my co-vertices. Left 2, 1, 2. And then to find c, we just need our formula. So c squared equals a squared plus b minus b squared. So that means c squared equals 21. So that means c then equals the square root of 21. Let's approximate that for graphing purposes. Square root of 21 is approximated to be 4.6. So from the center, I'm going to go up 4.6. 1, 2, 3, 4.6. Ready to foci there, down. And now let's just go ahead and graph. There you go. Okay. It says, given the graph of the following ellipse, write the standard form of the ellipse equation. Okay, so first off, we know this is a vertical ellipse. So that means a squared is going to go under y. We just need to find our center. Once we have our center, we can find a and b. So I'm just going to go the total distance from these two. I know these are my vertices here. Because we have a vertical ellipse, these are my co-vertices. Okay, and here we go. So we're going to go down 1, 2, 3, 4, 5, 6, 7, 8. So that's a distance of 8. So center has to be 4 down then because the center is smack dab in the middle of that total line. 4. Boom, so that's my center. So that means then A is 4. And then B equals 3 because from the center to my vertices, that's the definition of A. How far did we go? We went up 4. From the center to the co-vertices, that's my definition of B. How far did we go over? Total distance of 3. So now that I know A and B, and I know it's a vertical ellipse, and I know my center, I can write the equation out. So my center is, well, what is that? 1, 2, 3, 4, down 1, 2, 3, 4, 5. So positive 4, negative 5 is my center. And so we're going to write our equation like this. We're going to get x minus 4 to the second power. This is b squared going under here because we have a vertical ellipse. So if b is 3, b squared then would be 9. Plus, not x again, sorry. Y plus 5 to the second power over a squared. If a is 4, that's going to be 16. Equals 1, and there you go. There's your equation. So really, you just got to find your center, then your A and the B there with that, and you can write your equation. We knew it was a vertical ellipse because it's up and down like that to look, okay? All right, identify the characteristics of the hyperbola, then graph it. Okay, so recall, A squared is always under the positive fraction here. So that means then A squared equals 4, which is after you square it means that A is 2. That means B squared is equal to 49, which means then B is 7. And then for C squared, we're going to have C squared equals A squared plus B squared. So that's going to be 49 plus 4. C squared equals 53. C equals the square root of 53. I wonder if that simplifies or not. I can't think off the top of my head, so I don't think it does. Yeah, it doesn't. We just get 7.3 is approximated. Okay, and so C then is equal to the square root of 53. Our center, opposite H, so positive 2. K is 0 because there's nothing being added or subtracted to that y squared in the numerator there. Okay, so we know then that this is going to be a vertical hyperbola. So when we write out our vertices here, it's going to be 2, 0, and then what is A? A is 2. Well, actually, let's go ahead. Let's just graph. I like graphing it first, and then you can just read it off the graph. Okay, so our center is 2, 0. We know it's a vertical hyperbola. A is 2, so we're going to go up 2. Boom, vertices there, down 2. Vertices there. And so what are those points? That's over 2, up 2, so 2, 2. And then over 2, down 2, so 2, negative 2. Okay, our foci are up and down from the center, 7.3. So foci way up there, down. Okay, and so now let's go ahead. What are those points? So all we do is we take our center to 0, and the only thing that's changing is because we're moving up and down. The 2 is not changing the x value. We're just moving the y value up and down. We can write it like this: is 0 plus or minus square root 53. If you wanted to, you could do 2. You could actually determine what those points are, but it's a lot easier just to write it that way when you have a radical expression. Okay, my asymptotes, we need to do my covertices real quick. So B is 7. Okay, so when we start this box from the center to get to the top right corner here, we're going to go up A over B. Okay, how do I get to the top right corner? I go up A over B, so my asymptotes are going to be this. Okay, opposite H, it's going to, or I mean, it's just going to be y equals, because k is 0 in this case. If you want to do y minus 0, you can. It's going to be y equals plus or minus up A. A is 2 over B, which is 7. I went up 2 over 7 to get to the corner here. And then opposite of H, which is 2. So x minus 2. There's your equation for your asymptotes. And then your eccentricity is C over A. So that's just going to give me root 53 over 2. Let's going to finish graphing over here, okay? So recall, our slant asymptotes go through the corner of each box and through the center. Okay? Wow, this is going to be a really, really stretched out hyperbola here because the foci is so far away from the vertices here. All right, there you go. So there's your hyperbola there. Okay. 2 more on the back here. So we've got, write the equation of the hyperbola in standard form identified by the center, vertices, foci, graph, and label all that. Okay, so we need to go ahead and do complete in the square. So I'm going to move that over, okay, and I'm going to move the positive values in front first. So 16. So again, how do we know this is a hyperbola? Look at the value for the x squared is positive, the value for the y squared is negative. One of them is going to be negative. So I'm going to be left with this. So I'm going to have 16 x squared. Okay, I'm going to have 16x squared plus 32x minus 9y squared minus 54y equals 209. Okay, let's go ahead and factor out. So we factor out, we're going to get 16. It's going to leave me with x squared plus 2x. Now, because it's hyperbola, you factor out the negative as well. Minus 9. So that's going to give you y squared plus 6y equals 209. Okay, we're going to divide the b's now. So we're going to do 2 divided by 2 to the second power. So that gives me 1 to the second power, which is 1. 6 divided by 2 to the second power, so that's going to be 3 to the second power, which is 9. Now, what are you adding over here? Since you took out a 16, you added the 1, it's going to be 16 plus 1. Now, since you factored out negative 9, you added 9, it's going to be minus 9 times 9 there. And so what are we going to have? Let's look at it. So we're going to have 16 out front here, times, when I did 2 divided by 2, I got 1, so it's going to be x plus 1 to the second power, minus 9. Y, when I did 6 divided by 2, I got 3, so y plus 3 to the second power. And now let's put that in our calculator. So 209 plus 16 times 1 is 16 minus 81 gives me 144. And so for our standard, last thing we're going to do is again, divide everything through by 144. So my standard equation is going to look like this. It's going to be x plus 1 to the second power over 16 over 144. That's simplified to be 1 over 9, so 9 here. Minus 9 over 144. What is that going to get you? 1 over 16, so it's going to be minus y plus 3 to the second power over 16 equals 1, and there you go. So there's our standard form. Okay, there's our standard form. So now we can go ahead, we can write our center. So opposite h and k, so negative 1, negative 3. Okay. Since the x, this is positive right here, a squared is going to equal 9. Which means a equals 3. That means b squared equals 16. B equals 4. Again, remember with hyperbolas, the major axis does not have to be longer than the minor. Okay? That leaves me with this. That gives me then c squared equals a squared plus b squared. So then c squared equals 9 plus 16. Which means then c squared equals 25, c equals 5. So c is 5, a 3, b 4. Okay, let's go ahead and graph this. So negative 1, negative 3. Okay, since a squared is under x, this is going to be a horizontal hyperbola. So we're going to go left and right 3 from the center for the vertices. Vertices, my foci are also on the same axis as my vertices, so I'm going to go left and right 5 because c is 5. Let's go ahead and write those points in. So one vertice is going to be 1, 2, 3, 4. So negative 4, negative 3. The other vertices is going to be 1, 2, 2, negative 3. My foci really easy to see this time. It's down over 6, down 3. So negative 6, negative 3. Over 4, down 1, 2, 3, negative 3. All right, our co-vertices, just to help us draw our box here. So B is 4, so we're going to go 1, 2, 3, 4, down. Okay, and so now we're going to draw a box. And so, how are we getting to the top right corner here again? And when we write our asymptotes, we're going up B over A. So it's going to be this. So opposite of opposite K for Y, so it's going to be Y plus 3 equals. we're going up B over A, up B over A. So up 4 over 3 to get to the corner there, and then x plus 1, because opposite of h. Okay? Eccentricity C over A, so it's just going to be 5 over 3. Okay, and now let's go ahead and graph. Remember, slant asymptotes. Go through the corner of the box, through the center. Okay, now we draw from our vertices our hyperbola shape. And there you go. That is number 5. Okay, last one here. Again, looks like we're writing all the parts here. The standard form of the equation for the hyperbola is transverse axis has points negative 2, 1 and negative 8, 1. So let's graph that. So negative 2, 1 and negative, that's negative 2, 0. So negative 2, 1 is right here. Negative 8, 1. So that means that's our vertices right here, our endpoints. So then our center, 1, 2, 3, 4, 5, 6. Our center is going to be smack dab in the middle because, again, remember, our center is equidistant to the vertices. So that means I'm going to have 1, 2, 3. Here's my center. And so my center then is at negative 5, positive 1. We know what A is. A then is 3. Okay? Because from center to the vertices, that's A. We're going to go over 1, 2, 3, so we know A is 3. It tells me this says the conjugate axis is a length of 6. So the conjugate axis is always involved with our co-vertices and B. So that means then, since I know the whole length is equal to 6, I just do 2B equals 6. Okay? Because we know that our minor axis is equal to 2B, which conjugate is the same thing as minor, and transverse is the same as major, and that our major axis is equal to 2A. We talked about that with ellipses, so then B is equal to 3. So now that you have A and B, you can find C. So C squared equals A squared plus B squared, so 9 plus 9. So C squared equals 18. So then C equals 3 root 2. Which for graphing purposes, 3 root 2 is approximated to be 4.2. So now, we know we have a horizontal hyperbola here. We know we have a horizontal hyperbola because the vertices are to the left and right of the center. So when I write my equation, I'm going to have this. So it's going to be x 5 to the second power minus because A and B are the same here, you don't really have to worry about what goes with what. The only thing you need to know is that that minus sign needs to obviously be in front of the y instead of the x because we have a horizontal hyperbola. With the horizontal hyperbola, the x squared fraction is always positive. Okay? So my vertices, it already told me it's at negative 8, 1 and negative 2, 1. Okay? Your foci, because your foci is also going to be to the left and right of the center, you can write it like this. You can do negative 5 plus or minus because it's a radical number, 3 root 2, comma 1, which means I'm just going left and right, 4.2 from the center. So there's one foci to the right, 4.2. There's my other foci. And now to help us draw the box, we're just going to use B, which in this case, 1, 2, 3. Co-vertices down, 1, 2, 3. And that helps me draw the box. I just go over Okay, so there's our box. How do we find our asymptote? We always go, how do we get to the right corner? So we go up 3 over 3, so B over A, which again, when B and A is the same, it's nice, it makes it easy. So opposite of Y, so Y minus 1 here. I mean opposite of K for your asymptotes. Plus or minus B over B. Plus or minus B over A, which in this case is just going to be 1 times, okay, opposite of H there, X plus 5. And then eccentricity, just C over A. So 3 root 2 over 3, which just simplifies to be root 2. And last but not least, let's go ahead and finish graphing here. Again, slant asymptotes go through the corner of the box, okay, through the center. And now we just draw the hyperbola part. And there you go. Yeah, I mean, you probably don't have to stretch out that right side as far as I did, but it is what it is. It's fine. Okay, I mean, the graphing stuff, you guys are going to be assessed on next week when we do the project. Okay? All right, but that's it. That's the test review. And yeah, good luck with the test. Thank you. Bye.